Yes, good morning students. Yes, good morning students. Then in the previous class we already discussed few concept in that isomerism. So basically that isomerisms are two types, that is one structural isomerism and stereoisomerism. So what is the structural isomerism? These structural isomerisms are following types, that is one chain isomerism, position isomerism, functional isomerism, metamerism and then tautomerism. Chain isomerism nothing but compound having same molecular formula but different type of chain are called chain isomerism. These chain isomerism nothing but next to position isomerism, compound having same molecular formula but different type of position like multiple bond. That like multiple bond means halogen, alcohol and halogen position, multiple bonds like double bond, triple bond, alcohol, halogen, its position is change. After that functional isomerism, compound having same molecular formula but different type of functional group are called functional isomer, and the study of phenomena is called functional isomerism. Then alcohol group change to ether, carboxylic acid group change to aldehyde group change to ester, aldehyde group change to ketone, carboxylic acid group change to ester, and unsaturated unsaturated compound. Then cyanide change to isocyanide. So we already discussed that functional isomerism. Metamerism, compound having same molecular formula but different type of alkyl groups. Tautomerism, compound having it contain two fundamental concept. One, compound should have at least one electron withdrawing group such as CO, NO2 and Cn, and compound should have at least one acidic hydrogen on alpha carbon or one alpha hydrogen on acidic carbon, that are formed by tautomerism. The next one, quinonoid cannot be formed tautomerism. So how type that best example how to form we already discussed. After that what is elements of symmetry? These elements of symmetries are following types, that is one plane of symmetry, center of symmetry, asymmetry and symmetry. So after we already discussed optical isomerism having asymmetric carbon, based on that problem we already discussed. After that optical active compound containing one asymmetric carbon, optical active compound containing two asymmetric carbon. Those mirror image to each other, those are mirror image to each other, that are called enantiomer. Which not mirror image to each other, that are called diastereomers, So this we already discussed. Then today we discuss optical isomerism compound containing no chiral carbon atom. Today we discuss optical isomerism in compound containing no chiral atom. So here this is, there are four example is there, that is one allene, alkylidins, spirines and biphenyls. So these three are no chiral carbon. Now let us we discuss spirine. Now we discuss first example is allenes. What is the meaning of these allenes? These allenes, then today we discuss optical isomerism and geometrical isomerism. So this optical is containing no chiral carbon atom. So in this one allenes contain, this is the general formula. This is the general formula of allene. This is the general formula of allene. In this general formula, it is it contain like this example is formed: C double bond C double bond C. This is 1, 2, 3, 4. This side A, this side A, this side B, this side B. So this is cis compound. That means the two, this is cis. What happened in the trans? C double bond C double bond C. This side A, this side A, this side B, this side B. This is an trans. This is an trans. Allene contain 3 carbons and which contain two double bonds, it contain two double bond, and a few examples of here, for example like this, for example few examples. What is the allene example? I am doing for this side C6H5, allene formula C double bond C double bond C, here C6H5, and this side C10H7, C10H7, this side also C10H7, this is cis allene. Now one more example, C double bond C double bond C, and this side H, this side H, this side CH3, this side CH3. This is one type of example. Next, this is all contain cis. Next, this one C double bond C double bond C. These are like this. One compound contains CH3, one compound contains CH3, another contains C2H5. This is H, this is H. This is allene examples. Now, so allene contain carbon carbon that means two carbons, and this terminal carbon, this nothing but terminal carbon, this is the two terminal carbons, the two, this is cis compound, this is also cis, this is trans, this is cis. Next one, alkylidene. What is the meaning of this alkylidene? Second example is alkylidene. Alkylidene. So here, what is the definition of this alkylidene? So it contain carbon carbon, this is alkylidene, means this is the best example. This is one cyclic compound, this is carbon carbon double bond, and here A and B. This belongs to alkylidene. In this one, this side A and this side B. These examples of alkylidene. This is the general formula of alkylidene. So one of the carbon double bond is like this, other carbon is containing phenyl alkyl groups. That means cyclic compound. So that are called alkylidene. So here the best example of alkylidene is, so this is what happened, one of the group, this is C, this side H, and this side COOH, and this two compound, this is hydrogen, this is CH3. So this is one of the best example of alkylidene, The next, after that alkylidene, next one is spirenes. Spirenes. So this spirene nothing but, this is the formula of alkylidene. That spirene nothing but, so this is bicyclic spirene nothing but, this is the spirene. This is the formula of spirene. Now here this is A, this is B, this side A, this side B. This is spirene. And here if you discuss few examples of this spirene, these examples of spirene is, now like this. This is spirene, this side H, this side NH2, this side also H, this side NH2. This is cis spirene. What happened in the another one, for example of spirene, now take two carbon like this, this is one, and this is hydrogen, this is COOH, this side hydrogen, this side COOH, this is also spirene. Next, one more example. So these are the examples of spirene. So this is spirene. Next one, biphenyl compound. The fourth one is biphenyl. Biphenyl. So that biphenyl means it contain two cyclic compound. Are called biphenyl. So how to what is the examples of this biphenyl compound? Now we discuss one by one. So these biphenyl contain two phenyl groups. Biphenyl contain two phenyl groups. So how to draw the structure of this biphenyl? Now let us we discuss. So what is this biphenyl? Now fourth one is, so this is optical isomerism containing no chiral carbon, allene one example, alkyladenes, spiranes, and fourth one is biphenyls. So what is biphenyl? This biphenyl is very important. These biphenyl compound containing no chiral, that's why biphenyl means two phenyl groups are takes place. Biphenyl means two phenyl groups are takes place. Now, so what is the structure, which one is the cis, which one is the trans, how to identify that cis, how to identify the trans, now let us we discuss. So what is that? Biphenyl nothing but, this is the best example of biphenyl. Then fourth one is biphenyl, biphenyls. So what is the best example of these biphenyls? Now let us, for example, this is one of the phenyl group, and let us, this is another of the phenyl group. Okay. So one of the phenyl group nothing but, this is I am writing for the here side B and here side also B and here side A, and the bottom side this side B and this side B. So it is how to identify that. Now this side also one compound like this and this is another compound. Okay. So which contain this side B and here side also B. Now this side A and this side also A. So this is how to which is that means which is mirror image to like this, So that is no mirror image to each other. So no mirror image to each other, that's why this is biphenyl compound. So which one is the mirror image? Now for example like this, one of the compound this one and another of the compound this one, I am writing this side B and this side also B and this side A and this side also A. Now these are mirror image to each other if plane of symmetry. So this is plane of symmetry, this is plane of symmetry, this is no plane of symmetry, no plane, this is no plane of symmetry, that means above side is A, below side is B. So that's why it is no plane of symmetry, that's why it is plane of symmetry, it is no plane of symmetry, that examples are called biphenyl. Now few examples of biphenyl compounds, see it is also no plane of symmetry, few examples. For example like this, it is also no plane of symmetry. Now few examples of biphenyl compound, for example like this is one of the phenyl group and this is also one of the phenyl groups. So here A, this side A, it is also no plane of symmetry. So next one, another example like this is one of the compound, this is biphenyl, two phenyl, this side A and this side B, it is also no plane of symmetry. Next example for all contain like this is one of the phenyl groups and this is another of the phenyl groups, this side A, this side B, this side C, this side E, it is also no plane of symmetry. Next one, for example of like this is one of the compound, this is here COOH, this is COOH, this is NH2, this is NH2, it is also no plane of symmetry. Last, so these are contain no plane of symmetry, no chiral carbon atom. So the best example of biphenyl. Now here this contain what happen? Optical isomerism compound containing no chiral carbon atom. So after this no chiral, after this topic we discuss geometrical isomerism. What is the geometrical isomerism? This geometrical isomerism nothing but cis trans isomerism. Geometrical isomerism nothing but cis trans isomerism. That cis means to next topic is goes to geometrical isomerism. So that geometrical isomerism nothing but cis trans isomerism. That cis means that two identical group are in same inside are called cis isomerism. The two identical group are in different side are called trans isomerism. So this one compound is formed cis trans, one compound is formed cis trans. There are few fundamental concept. Compound containing at least double bond, that means double bond will be takes place. The double bond will be takes place means that is either carbon carbon double bond or carbon nitrogen double bond or nitrogen nitrogen double bond is there that are form geometrical isomerism. And so what is that geometrical isomerism? These geometrical isomerisms are basically two types, that is one cis trans isomerism and first geometrical isomerism. Geometrical isomerism. Geometrical isomerism. So nothing but this geometrical isomerism nothing but cis trans isomerism. Geometrical isomerism is nothing but cis trans isomerism is nothing but cis trans, cis and trans. Cis means same side, cis means same side, trans means opposite side. Cis means same side, trans means opposite side. So for example, compound should have compulsory here following example, carbon carbon double bond is compulsory takes place either this one or carbon nitrogen double bond and nitrogen nitrogen double bond. If no double bond, it cannot be formed cis trans isomerism. So the best example of cis trans geometrical isomerism is like this: CH3 CH double bond CH CH3. So how to draw this one? C double bond C, this side CH3, this side CH3, and this side H, this side H. This is cis isomerism. What happened? Trans C double bond C, this side H, this side H, this side CH3, this side CH3. This is trans isomerism. So that's why two butene is formed cis trans isomerism. One another example, C6H5 CH double bond CH COOH. So how to form this cis trans isomerism? C double bond C, this side C6H5, this side COOH, this side H, this side H. This is an cis. What's happened in the trans? C double bond C, this side COOH, this side CH3, this side H, this side H. This is trans isomerism. The two, what is cis trans? The two identical group are in same inside. The two identical group are in same inside are called cis isomerism, and then two identical group are in different side are called trans isomerism. Two identical group are in same inside are called cis isomerism, and two identical group are in different side are called trans isomerism. Cis means same inside, trans means different side, that means opposite side. Trans means opposite side or different side. So this is geometrical isomerism. Now let us discuss few examples of geometrical isomerism. Let us discuss few examples of geometrical isomerism. So these few examples of geometrical isomerism nothing but what happened? See this one also some examples of oxime. Oxime is also formed geometrical isomerism. What is the formula of oxime? C6 this is oximes. Next example is oximes. Oximes is also formed geometrical isomerism. What is the formula of oximes? Here formula of oxime is CH3 CH3 CH double bond NOH. CH3 C double bond NOH, and this is one, it is also oxime. Next example like this, C6H5 CH double bond NOH. It is also one of the example. Next one C6H5 CH3 double bond NOH. They are formed, this all contain geometrical isomerism. This all contain geometrical isomerism. The all contain geometrical isomerism nothing but cis trans isomerism. Next one, for example, like this one also form geometrical isomerism. So, this is not form geometrical isomerism. CH3 CH3 double bond NOH. It is no form of geometrical isomerism. No form of geometrical. This examples is no form of geometrical isomerism, and it is also no form of geometrical isomerism. HC double bond NOH. It is also no form of geometrical isomerism, and like this is also no form of geometrical, like this C6H5 C double bond NOH and C6H5. So, these three examples are no form of geometrical isomerism. This is no form of geometrical isomerism. It is also no form of geometrical isomerism. So, this is called geometrical isomerism. For example, so this geometrical isomerism due to carbon-carbon double bond. Geometrical isomerism is due to carbon-carbon double bond. So, what is the meaning geometrical isomerism? Geometrical isomerism, geometrical isomerism due to carbon-carbon double bond, So, what I discussed in this one here, this is carbon-carbon double bond, this is carbon and nitrogen double bond. So, those are formed geometrical, and the two identity group are in same inside are called cis. The two identity group are in different side are called trans. So, for example, here this is here few example for this one. One cis2 butene, that means we already discussed this one, CH3 CH double bond CH single bond CH3. This is 2 butene. This is 2 butene. C double bond C, this side what happened, 4 identity group are is there. So, I am different identification of this group. So, one side is CH3, this side CH3, this side also CH3, this side hydrogen, this side hydrogen. So, the two identity group are in same inside, that is why this is cis2 butene, cis2 butene. So, what happened in the trans, C double bond C, this side CH3, this side CH3, this side hydrogen, this side hydrogen. This is trans 2 butene, trans 2 butene. This is trans 2 butene. So, now one more example is there, that is cinnamic acid. So, what is the cinnamic acid? Cinnamic acid formula is like this C6. Now, one more example for this one, cinnamic acid, cinnamic acid. So, what is the formula of this cinnamic acid? This cinnamic acid also the best example of this geometrical isomerism. How to form that cinnamic acid is formed geometrical isomerism. So, this cinnamic acid is formed. Okay, na sir? The cinnamic acid formula is C6H5 CH double bond CH COOH. This is cinnamic acid. This is form cinnamic acid. So, what is the formula of cinnamic acid? Okay. Now, the one more, the best example of this cis trans is cinnamic acid. Cinnamic acid. So, this cinnamic acid is also formed cis trans isomerism. This is the best example of this one, C6H5 CH double bond CH COOH. This is cinnamic acid. So, how to form this is C6H5, CH double bond CH, COOH, then H, this side H, this is cis-cinnamic acid, cis-cinnamic acid. What is trans? C double bond C, COOH, then C6H5, H and H. This is trans-cinnamic acid, trans-cinnamic acid. For example, like this, here C double bond C, this side fluorine, chlorine, bromine, iodine. These 4 different group is there, fluorine, chlorine, bromine, iodine. So 4 different group is there. It is no form of geometrical isomerism, no geometrical isomerism. It is no form of geometrical isomerism, but it can be formed EZ configuration. It can be formed EZ configuration. Now let us we discuss what is EZ configurations. Now this now let us we discuss EZ configuration. What is the meaning of this EZ? E here, E means opposite side, E means opposite side, Z means same side. E means opposite side, Z means same side. So that means the 2 higher atomic number, are in opposite side are called E configuration. The 2 higher atomic number are in same inside are called Z configuration, configurations. Now what is the examples of E and Z configuration? Now let us examples. So the 2 higher atom, what is the EZ? Now E means opposite side, Z means same side. Now let us we discuss EZ configuration. Now next one is EZ configuration. EZ configuration. Here E nothing but E equal to opposite. E means opposite. Here E nothing but opposite. Z equal to same side. Z equal to same inside. Now what is the best example of EZ? Here C double bond C. Now here fluorine, this side chlorine, this side bromine, and this side iodine. Now in this one, how to identify this one? This is just you have to remember this one: fluorine, chlorine, bromine, iodine. Fluorine atomic number is 9, chlorine 17, bromine 35, iodine 53. Now here fluorine atomic number is 9, bromine 35 and chlorine 17, iodine 53. So that means the 2 higher atomic number, are in same inside. The 2 higher atomic number, same side are called, this is Z configuration. This is what happened? Z configuration. This is Z. What happened in the E? C double bond C. I am writing different what happened? Different color. So fluorine, chlorine, bromine, iodine, like this. Fluorine, this side fluorine. Sorry, this is the 2 higher atomic number are same inside. Here Br, iodine. Sorry. Now little bit change of this. Only for the here. I am changing only one carbon, one halides, C double bond C, this side fluorine, this side chlorine, but this side iodine, this side bromine. So what happened? Just now we already told. So fluorine atomic number is 9, fluorine 9, chlorine 17, bromine what happened? 35, iodine 53, iodine 53. So what we observed, the two higher 53 plus 9, 53 plus 9 is 62, 35 plus 17 is nothing but 52. The two higher atomic number, the 53 plus 17, 53 plus 17, 70. The two higher atomic number are in opposite side, that are called E configuration, that are called E configuration. Z means the two higher atomic number are in same inside, the two higher atomic number are in same inside, the two higher atomic number are in same inside are called what happened? Z configuration, and the two higher atomic number are in opposite side, that are called E configuration. Now let us one example for this one. Another example, see we already discussed that cis 2-butene. Now CH3, C double bond C, this is H, this is CH3, this is H. So what happened? The two higher atomic number are in same inside. So that's why this is Z configuration. Now C double bond C, this side, CH3 this side, CH3 this side, H this side, H. This is E configuration. This is geometrical isomerism. Next one, number of geometrical isomerism in polyenes. Geometrical isomerism nothing but cis trans isomerism. Geometrical isomerism is nothing but cis trans isomerism. That cis means the two identical group are in same inside are called cis, and trans means the two identical group are in different side are called trans. So this is one of the geometrical isomerism. After this, number of geometrical isomerism in polyene. Number of geometrical isomerism in polyene. So here that number of geometrical isomerism polyene, there are 3, that means both end will be same, both end will be different, both end will be different, but number of double bond is poly, but number of double bond is poly. Now that formula is 2 power n, that formula is 2 power n. So now if number of double bond is poly and both end will be different, so how to calculate it? How to calculate it? So now that is geometrical isomerism, number of geometrical isomerism in polyene. Next topic is goes to number of geometrical isomerism in polyene. Number of geometrical isomerism, geometrical, number of geometrical isomerism, number of geometrical isomerism in polyene, isomerism in polyenes, polyenes. So what is the meaning of this one? For example, let us take one example, we will discuss one example. Both end will be different. Now here C6H5, CH double bond, CH single bond, CH double bond, CH single bond, CH double bond, CH 1 2 3 double bond, sorry, this is single bond, here single bond, CH single bond, CH 1 2 3 double bond, CH 1 2 3 4 CHCl. Now here C6H5, here chlorine, both end will be different, but number of double bond is poly, but number of double bond is what happened? Poly. So that what happened? 1 2 3 4. So number of geometrical isomerism, number of geometrical, geometrical, number of geometrical isomerism, isomerism, number of geometrical isomerism equal to formula 2 power n, 2 power n. Now in this one n equal to 4, that means 1 2 3 4, that's why 2 power 4, what happened? 16. Number of geometrical isomerism formula is what happened? 16. Next one more problem. So both end will be same, but number of double bond is even one type of formula, and number of double bond is poly double bond is odd there one type of formula. So now how to calculate that number of double bond even number and odd number. Now, here two formulas is there. Now, if we discuss this one, this is C. So, what is that? Number of both end will be same, but number of double bond will be even. Second formula. So, this contain first one. Now, we discuss second. So, what is the second formula? This is second one. Both end will be same, both end same, but number of double bond is polyene. Both end same, both end same, both end same, but number of double bond is even, Now, what is the formula? Now, let us see. So, if even is there, which formula is 2 power n minus 1, this is the formula, 2 power n minus 1 minus 2 power n by 2 minus 1. This is the formula for this one. This is the formula for this one. For example, even nothing but this is the example, Cl, CH, double bond, CH, single bond, CH, double bond, CH, single bond, CH, double bond, CH, single bond, CH, double bond, CH, Cl. 1, 2, 3, 4. Number of double bond is even. That means what happen? N equal to 4. Here what happen? N equal to 4. Now, you have to use this formula, 2 power 4 minus 1 minus 2 power 4 by 2 minus 1. 2 power 3 minus 2 power 2 minus 1. 2 power 3 minus 2 power 1. 2 power 3 nothing but 8 minus 2 equal to 6. Number of geometrical isomerism possible is what happen? 6. So, sorry, 2 power, this is just formula is to this plus. So, that is why what happened? 2 power plus, and this side what happened? 2 power 10. Number of geometrical isomerism in the polyene, that means both end will, what is the difference between there? This is C6H5, this is Cl. Both end will be different, but number of double bond is poly. Now, this is this one. Both end will be same, but number of double bond is poly, even. Number of double bond is even, that contain what is the formula? 2 power n minus 1 plus 2 power n by 2 minus 1. Now, what happen? Here, next formula is third one. What is the formula? Both end will be, both end same, but number of double bond is odd. Both end same, but number of double bond is odd. Number of double bond is odd. So, odd nothing but what is the formula? I am using this formula. So, 2 power n minus 1, this is the formula, 2 power n minus 1 plus 2 power n plus 1 by 2, 2 power n plus 1 by 2 minus 1, 2 power n plus 1 by 2 minus 1. So, how to calculate this? How to calculate of this? For example, I am using one calculations, one problem, same problem like this, Cl, CH, double bond, CH, single bond, CH, double bond, CH, single bond, CH, double bond, CH, Cl. Both end will be same, but number of double bond is odd. Number of double bond is odd, nothing but what is? N equal to 3. Here what happen? N equal to 3. You have to use this formula, 2 power 3 minus 1 plus 2 power 3 plus 1 by 2 minus 1, 2 power 2 plus 2 power 4 by 2 minus 1, 2 power 2 plus 2 power 2 minus 1, 2 power 2 plus 2 power 1. So, what happened? 4 plus 2 equal to 6. 4 plus 2 equal to 6. That means, now what is the observed in these three? Number of geometrical isomerism in polyene. Here double bond 1, 2, 3. This is what happened? Both end will be same. Both end will be different. So, what is the here? Both end different. Here both end both end different, both end different, but number of double bond is polyene, but number of double bond is poly. So both end will be different, number of double bond is poly, or call this one type of formula. Geometrical isomer is nothing but 2 power n. Geometrical isomer is nothing but 2 power n. Both end will be same, but number of double bond is even. You have to imagine it for this. Both end will be same, but number of double bond is even. Here both end will be same, but number of double bond is odd. So what is even? 2 power n minus 1 plus 2 power n by 2 minus 1. Here 2 power n minus 1 plus 2 power n plus 1 by 2 minus 1. So this is what is number of geometrical isomerism in polyene. After geometrical isomerism in polyene, physical properties of cis-trans isomerism. Physical properties of cis-trans isomerism. What is the meaning of this physical properties of cis-trans isomerism? So I will give a good technique for this one. Physical properties of cis-trans isomerism. So next one, a small topic, physical properties of cis-trans isomerism. I will give a good technique for this one. Now physical properties of cis-trans isomerism. Next one, physical properties of cis-trans isomerism. So what is the physical properties of cis-trans isomerism? Physical properties of cis-trans isomerism. Cis-trans isomerism. Cis-trans isomerism. So what is the physical properties of cis-trans isomerism? Now first point is melting point. First one, melting point. Melting point. What is melting point? Melting point of cis is, melting point of trans is more than cis. So trans is, melting point is, trans is more than cis. Trans is more than cis. Trans is more than cis. So this is trans. Here what happened? COOH, and this side also COOH, this side H, this side H. This is cis. What happened? Trans, C double bond C, this side COOH, this side COOH, this side H, this side H. So this melting point is 302. Its melting point is 302. Its melting point is 130. So how to identify? M, जो M letter is followed by Mn, it is nearby T. M is nearby T, that's why melting point is trans is more than cis. For example, boiling point, see observed, boiling point. Second one is boiling point. Boiling point is followed by cis. Cis is more than trans. Boiling point, cis is more than trans. More than trans. So what is boiling point? C double bond C, this side H, this side H, this side chlorine, this side chlorine. Its boiling point is 66.3 degrees. C double bond C, this side H, this side chlorine, this side chlorine, this side H. Its boiling point is 48.4 degrees. That means boiling point of cis is more than trans. Next one, dipole moment. Dipole momentum also same thing. What is dipole moment? D is followed by D is nearby C is there, cis is there. D nearby C. That's why dipole momentum of cis is more than trans. That means cis isomerisms form certain dipole moment, trans isomerism form cannot form, that means that means less than that what happened, so dipole moment. Third one is dipole moment, dipole moment. Dipole moment, what is the dipole moment? Dipole momentum of cis is more than trans. Dipole momentum of cis is more than trans. Dipole momentum of cis is more than trans. So that's why cis contains certain dipole, that means mu cis is greater than mu trans. Mu cis is greater than mu trans. That's why cis isomerisms form certain dipole moment and trans is cannot form certain dipole moment. So that's why here it is 100% C double bond C, this is hydrogen, this is hydrogen, this is chlorine, this is chlorine. Its mu is 1.85. C double bond C, this is hydrogen, this is chlorine, this is chlorine, this is hydrogen, this is mu is does not equal to 0. That means it is 0, trans is nothing but 0. The next one, solubility. Next one, what happened? Solubility. What is the solubility? The solubility also trans is more than cis. Solubility, trans is more than cis. Trans is more than cis. Next to fourth physical property, then solubility. Fourth one, solubility. Solubility. Solubility, S is nearby trans. S value is S letter is followed by trans. That's way trans is more than cis. Trans is more than cis. This solubility. Next one, except to stability. Stability is completely different. Next one, stability. Fifth one is stability. Stability. This stability is different. Stability is different. That is, cis is more than trans. Cis is more than trans. This is what happened? Geometrical isomerism. Geometrical isomerism nothing but cis trans isomerism. That cis means cis nothing but what happened? And one more, stability and action of heat. So this, okay, and one more example for this one. For example, this is cis compound HC double bond C, this is COOH, this is COOH, this is H, this is cis. In the presence of certain temperature, like 150 degree centigrade, to get this compound is formed HC, then double bond C, H, then C double bond what happened? C double bond O, C double bond O, oxygen. This is acetic anhydride, but strand C double bond C and this side COOH, and what happened here? COOH and this side H, but it is no product. It is no product. So cis to get acetic anhydride, but trans it will be formed no product. So this is geometrical isomerism. So this geometrical isomerism nothing but cis trans isomerism. Cis means two identity group are in same side are called cis. Trans means two identity group are in different side are called trans. So I will give a good technique for this one, physical properties of cis trans isomerism. Here melting point. So just you have to remember melting M letter nearby T. So you have to remember only C and T. M letter is nearby T. That's why trans is more than cis. Trans is more than cis. B, boiling point. Boiling point what happened? B is nearby C. So that's why boiling point of cis is more than trans. Dipole moment D is nearby C. Cis is more than trans. Now solubility, S letter is nearby T. Trans is more than cis, but stability is different. stability is different, but it is not T, but cis is more than trans. Just this cis compound is cannot form, cis compound is form acetic anhydride, trans is cannot form no product, trans is form no product. This is geometrical isomerism. And one more topic of geometrical isomerism is there, that is what is syn, what is anti, that to be continue on next class, to be continue on next class. Okay.